Class 10th. Today we'll start the chapter number 8, Introduction to Trigonometry. This is the new concept in our maths as in this class 10th. We are not familiar with the word trigonometry. So let's discuss about this. Mainly this word trigonometry is the combination of three words, trigon and metron. That is, tri is 3, gon is side and metron is measurement. So the meaning of this word trigonometry is 3 side measurement or measurement of 3 sides. Here the concept for the figure or geometric figure which is made by 3 sides is a triangle. Then we can say that trigonometry deals with the measurement of sides of triangle. Let observe this figure. A boy is flying a kite. If we want to find what is the height of the kite from the ground, so as the boy is standing and the string of the kite is in his hand, so we know the height of the boy. So this line which is drawn, that is base distance which is parallel to the ground, and for the finding the height of the kite we have to find this height, and when we add this height with the boy's height we can get the total distance of the kite or height of the kite from the ground, where the string of the kite is in his hand, from where this is known as the length of kite from the boy. So we can find out by this triangle the height of the kite from the ground. Let's take one more example. If a tower is there and one person observes from this point, and when he look at the top of the tower, this line is the distance of tower from the observer's eye as he is looking from this point. This is known as the height of the tower, and the horizontal distance, this is the distance between the observers and the tower. Again we are having a triangle. The main feature in both the examples is both the triangles what we are getting in this are the right angled triangle. So by these two examples we can say now the trigonometry deals with the measurement of sides of right angled triangle, and we can say it is the measurement or analysis of right angled triangle. So there's question arises, what type of measurement? So in this chapter we are going to develop this relation between the angles and the sides of the triangle. So let ABC is a triangle, as we know that if the ABC is a triangle right angled at B, so B is 90 degree. So for the rest of the two angles we have angle A plus angle C is equal to 90 degree. This is the relation of angles only. And by the Pythagoras theorem we know that hypotenuse square is equal to perpendicular square plus base square, and this is the relation between the sides. What about it when we combine these two relations, angles and side? Can we write the relation which define angles as well as the sides? So let's discuss. Again, let the same example, when observer observes a tower where AB is the height of the tower and BC is the distance from the observer to the base of the tower, and we observe from C. So AC is the distance from the top of the tower to the observer. So here we are getting a right angle triangle ABC. We can find the ratio of the sides of this triangle ABC as perpendicular and base AB upon BC. Let it has some value. What about that? When one more tower behind this tower at the same point, again that observer can observe this tower. Second one, that the DE is the height of the tower, and at the same point C, same observer observing the height of the top of the tower, that is the line segment CD, and the distance between the tower and the observer is EB, and DE is the height of the tower. So in this, both the triangles ABC and DEC at the same point, that is from the same angle, we are observing the top of the two different towers behind one another. So in this triangle DEC also we can find the ratio of the side, that is DE upon EC. Let it has also some value. Now one interesting thing is here that the ratio for both the triangles what we are finding, perpendicular and base, it is same with respect to angle C, as from the angle C we are observing. Why it is same? As we know that ABC and DEC are the right angle triangle and angle C is common for them, that is both the triangles are similar. So by the similarity condition also we can write the ratio is same. So here we are getting the ratio of these sides are same, and if we write the same, so we can say AB upon BC is equal to DE upon EC, and if it is denoted by any variable, let it is name constant. So by this we can conclude that the ratio of any two sides of a right angle triangle is depend on the angle of triangle. This concept develops that there is the relation between the sides and angles of the triangle, and that relation is the trigonometric ratios. So we can understand that what is the trigonometry? It is the branch of mathematics which deals with the relation between sides and angles between these sides of triangles. So we relate this with the help of the trigonometric ratios which deals with the right angle triangle and with acute angles. It deals with the 90-degree angles or acute angles which is less than 90 degree, but in the 10th class we have to study for only acute angles, as the trigonometry deals with the angles more than 90 degree, but in the class 10th we have to study for the acute angles only. So let we draw a right angle triangle ABC where angle B is 90 degree and angle C is an acute angle, and we know that AC is the hypotenuse, AB is the perpendicular of the right angle triangle ABC, and BC is the base. So here when we are taking the acute angle is C, it is denoted by theta. So the side which is opposite to the angle theta is perpendicular and it is known as opposite side, and the side on which this triangle's angle theta is there, that is known as adjacent side. So we can say we take acute angle C, then the perpendicular is AB with respect to the angle C, that is theta, and similarly BC is the base with respect to angle C, that is theta. So question arises, what will happen if we take angle is A? Now when we take the angle A is acute angle, then Again, if angle B is 90 degree and we are taking A as an acute angle and denoted by theta, so the side which is opposite to the theta is the perpendicular, and the side which is the base for this acute angle theta is adjacent side. So by this figure we can get very easily that angle theta is here, so side which is the perpendicular is the opposite side, side which is the base is the adjacent side, and as we know that this is the hypotenuse, the side which is opposite to the 90 degree. So the relations of side with respect to acute angle defined as theta called the trigonometric ratio. This relation is the trigonometric ratio. Let in this given triangle, when acute angle is theta, then the side opposite to it is called opposite side. The side which is base of this angle theta is the adjacent side. Now there are main three basic relations of these sides and angles. So we can say the three basic functions in trigonometry. They are: first is sine. It is called sine, and the relation is sine theta is opposite side upon hypotenuse side. Whatever the angle, whatever the acute angle we define, the side opposite to this acute angle is the opposite side, and the ratio of opposite side upon hypotenuse is the sine of theta. Second ratio is cosine, and it is known as cos, and the relation for the sides, cos theta, theta is the angle which is equal to adjacent side upon hypotenuse, and the third ratio we can say that is tangent, and we say it tan. So the relation between the angles and side, tan theta is equal to opposite side upon adjacent side. Now there are three more relations in the trigonometry which are the inverse of these three. That is, the next three are made by above three main relations. So the next relation is cotangent, and it known as 1 upon tan, and we call it as cot theta. Cotangent is written as cot theta, and this is as the inverse of tan. So the relation of angles and side is for tan theta is opposite upon adjacent. So for cot theta we have adjacent side upon opposite side. For the second next relation inverse, which is inverse of cos, is known as secant, and we say it sec theta, that is hypotenuse upon adjacent side. And the third one is cosecant. It is the inverse of sine theta, and it is called as cosec theta, and it is hypotenuse upon opposite side. So we conclude the ratios of the trigonometries, or the trigonometric ratios are mainly there are three ratios, and next three we get by the main three ratios by taking inverse of these. So first of all, first is sine theta, that is the perpendicular upon hypotenuse. Cosine theta, or we can say cos theta, that is the base upon hypotenuse. Now base, that is known as the adjacent side. So when we are taking the right angle triangle, we know it as hypotenuse, base and perpendicular. So the side adjacent to the theta is the base. So adjacent side we replace it word base. Then tangent, that is tan theta, is perpendicular upon base. Cotangent, that is the cot, and which is the inverse of tan. So it is base upon perpendicular. And secant, that is the sec theta, inverse of cosine or cos, is hypotenuse upon base. and cosecant, that is cosec theta, and it is inverse of sine, so it is equal to hypotenuse upon perpendicular. Now when we have to remember these relations, there is a trick to remind these. If we are writing sine cos 10, so these three are main. So for remembering the ratios of these sides, there is a saying sine cos 10. In the same sequence we have to write sine cos 10. So in the numerator place we have to write P B P upon H H B. That is, in general term, we can say Pandit Badri Prasad Har Har Bole. So 3 words in the place of numerator and 3 words in the place of denominator. So easily we can remember the relation of sides for sine, cos and tan. That is, sine is perpendicular upon hypotenuse, first letters, cosine that is base upon hypotenuse, and tangent is perpendicular upon base.